In statistics, we often need to combine random variables by addition or subtraction. And when we do that, we need to be able to figure out what the mean of the combined random variable is, or what the variance or standard deviation of the combined random variable might be. So these are the rules that explain all that. If x and y are random variables, then the mean of the sum of x and y is the mean of x plus the mean of y. And the mean of the difference of x and y is the mean of x minus the mean of y. This makes intuitive sense. We have two variables, we're adding them together. Their mean should be the sum of their individual means, and the mean of the difference should be the difference of their individual means. That's all that's saying. Now, if x and y are independent random variables, then these are the rules that describe variances. The variance of the sum of x and y is equal to the sum of the variances of x and y. And then the variance of the difference of x and y is equal to the sum of the variances of x and y. So these rules for variances are very important. This only works if x and y are independent random variables. And you notice here, whether we add the random variables together or subtract one from the other, the variances always add. And that's the key thing to remember when you're working with variances. The variances add. Another thing to notice is that the standard deviations will not add. It's the variances that add. Okay? So variances always add regardless of whether the variables themselves are added or subtracted. And remember that the variances are added, not the standard deviations. People want to cut corners and add or subtract standard deviations. That is not going to work. You have to treat this like a situation involving the Pythagorean theorem. You might see this as being analogous to c squared equals a squared plus b squared, and in fact it is. Some people call this the Pythagorean theorem of statistics because of that. And the condition that you have independent random variables is analogous to the condition with a right triangle, that you have a right triangle before you apply the Pythagorean theorem to it. So they call this the Pythagorean theorem of statistics for good reason. Now, if x and y are not independent, then the rules for variances are much more complicated. You have to do what we did before, but then you have this third term, which is 2 times this Greek letter rho times the product of the standard deviations of x and y. This rho is the correlation between x and y. If x and y are independent, then this will be 0, and that term will go away, and we're back to where we were before. But if rho is not 0, then we have to take that into account when we add or subtract our random variables. In terms of an AP statistics course, this is not something that you're going to come across very often, and it's not a variable that it's not a rule that you're generally going to have to work with. And so most of the time you're going to be able to assume or to demonstrate that your random variables are independent, and then you can use the rules for independent random variables that we saw a minute ago. You won't have to use these. If you think about geometry, now this rule up here is analogous to the law of cosines in trigonometry, and just the way the law of cosines has the Pythagorean theorem as a special case, these rules have the Pythagorean theorem of statistics as a special case. Now here's some examples that show how this works. We're going to want to find the mean and the standard deviation of the combined random variables using these basic means and standard deviations, and assuming that x and y are independent. The mean of x plus y is the mean of x plus the mean of y, which is 60 plus 16, or 76. The variance of x plus y is the sum of the variances of x and y. So you're going to have to square that 15, and you're going to have to square that 4. And then you add them together, and you get 225 plus 16, which is 241. And then you can take the square root of that to get your standard deviation. It's about 15.52. When you subtract x minus y, the mean of the difference is going to be the difference of the means. That'll be 60 minus 16, or 44. The variance of the difference is the sum of the variances. Remember, variances always add, and that would be 15 squared plus 4 squared, which is again 241, same as before. And the standard deviation of 2 is the square root of 241, which is again 15.52. So it doesn't matter if you're adding the random variables together or subtracting one from the other. The standard deviation is going to be the same in either case. If we make this complicated random variable 5x plus y, the mean of that is going to be 5 times the mean of x plus the mean of y, which would be 5 times 60 plus 16, or 316. The variance of 5x plus y is going to be 5 squared times the variance of x plus the variance of y. So 5 squared times 15 squared plus 4 squared is 5,641, and the square root of that is about 75.11 for the standard deviation. And then a fourth example, 2x minus 3y. The mean is going to be 2 times the mean of x minus 3 times the mean of y. 2 times 60 minus 3 times 16 is 120 minus 48, or 72. The variance of 2x minus 3y is 2 squared times the variance of x plus 3 squared times the variance of y. And that works out to be 1,044, and the square root of that is the standard deviation, 32.31. Now here's some examples you can work on your own. I'm going to find the mean and the standard deviation of the combined variable. Assume initially that the mean of x is 24 and the mean of y is 40, and the standard deviations of x and y are respectively 8 and 10, and x and y are independent. We want to find the mean of x plus y and the standard deviation of x plus y, and also for x minus y, 2x plus y, and 4x minus 3y. So you can stop your video, take your time, come back when you're finished. Okay, welcome back. Here are the answers. The mean of x plus y is the sum of their means, which is 24 plus 40, or 64. The variance of x plus y is the sum of their variances. 8 squared plus 10 squared is 164. The standard deviation is the square root of that, or 12.81. On the second one, where we take the difference in x and y, the mean of the difference is the difference of the means. 24 minus 40 is negative 16. The variance of the difference is the sum of the individual variances, and that again is 164, because variances always add, and then the standard deviation again is 12.81. When we're looking at 2x plus y, the mean of 2x plus y is 2 times the mean of x plus the mean of y. 2 times 24 is 48, plus 40 is 88. The variance of 2x plus y is 2 squared times the variance of x plus the variance of y. So that's 2 squared times 8 squared plus 10 squared, or 356. And the square root of that is your standard deviation. It's 18.87. And then finally, the mean of 4x minus 3y is 4 times the mean of x minus 3 times the mean of y, which is 4 times 24 minus 3 times 40. That works out to be negative 24. It's 96 minus 120. And then the variance of 4x minus 3y is 4 squared times the variance of x plus 3 squared times the variance of y, and that works out to be 1,924, and the standard deviation is the square root of that, about 43.86. We're going to use these rules for means and variances a lot. We're going to be doing a lot of problems where we're going to have to combine random variables together and see how the linear combination of those random variables behaves, and understanding how you can calculate the mean and the standard deviation will be essential to that work.